Okay, so today we're looking at 5.1 as well as a little bit of review stuff. Here I've got a quadratic equation, a quadratic function. You'll see it's in function notation. Now, if it is quadratic, that means the biggest exponent is a 2, is x squared. Now, just giving you kind of a rundown of terminology here. If you're talking about the term that has the x squared in it, that's called the quadratic term. The term that has the x to the first in it is called the linear term. Remember, a linear equation's one that's something like this. It doesn't have the quadratic part. The x to the first power is the biggest. That's why it's called linear. And anything that's just a number is the constant term. Now, you'll need to know these just when I use those words. So if I talk about the quadratic term, you'll want to know what I mean. Okay, now before we move on a little bit, I want to just make sure that we practice a little bit with FOILing. Make sure that you remember that. Remember that FOIL stands for the F is first. You'll multiply first times first. Outside, you'll multiply outside times outside. Inside is the I, the inside terms. And last, the last times the last. So let's go through and let's multiply here. So we will have first, so x times x is x squared, outside, inside, 1x, I can just write it as x, and last. Now this is my answer. You'll probably be able to simplify, so I'm going to combine those like terms and get 8x. Alright, so FOIL, get good at it because it's going to be there for a long time. So let's FOIL these. So I'll have first, outside, be careful on your positives and negatives, inside, and last. And then combine like terms if you can, and you usually can in the middle. Now, not every time, but usually. Okay, 2 more of these. So first, outside, inside, and last. Combine like terms. Now remember, this one's negative, this one's positive, so I have positive 3x. And then same thing here. First, outside, inside, and last. And then combine if you can. Now FOILing is going to be like some other things we have this year. It's going to pop up a lot. So make sure that you get the process down because you're going to see it quite a bit. Now I want us to go through, simplify these down, and classify each of them as being either linear or quadratic. Remember, if it's linear, its biggest exponent is an x to the first power. If it's quadratic, the biggest exponent is x to the second power. Later on we'll have some that are bigger, but right now we only have linear or quadratic. Okay, so let me simplify this thing and see what I get. So I think I can FOIL this together. I'll just leave the y equals. So first, outside, inside, last, and combine my like terms. Okay, now looking at this, you'll see that your biggest exponent is an x squared right there. Now, if the biggest one is a squared, it's quadratic. Okay, let's do one more. So I'm going to simplify these down. So I have 3x squared minus 6x. Distribute out here. Now I'm going to get a little bit of canceling to happen with the 3x squared and the negative 3x squared. So I end up then with f of x equals negative 6x plus 6. Okay, now y'all think about it. Is this one linear or quadratic? Okay, I can't really get you to answer, so see if you got the same thing I did. This is linear because the biggest exponent is x to the first power. The quadratic part's canceled. So this is linear. Okay, now here in this chapter, we're going to be looking at different kinds of quadratics. I want you to see, generally speaking, what their graph looks like. Generally, your graph's going to be what's called a parabola. I'm not sure why this thing I copied and pasted had an upside down one first. This is kind of your general parabola. This is if you've got a negative in front of it, kind of like if we had a V, the V, if it was negative, was upside down. Now, I want you to notice a couple of things about this generic one. It starts here at 0, 0. You'll see that you can go up 1 over 1 and land on a point, but you cannot continue doing that. Center at 0, 0 on the generic one. Now, let me give you a few little details about parabolas. Parabolas are U's. They're kind of shaped like this. Now, U's is kind of a general term, not exactly a U. The vertex is the tip of your parabola. Now, you're going to hear that term, vertex, with a lot of different types of graphs in the future. The vertex is always the turnaround point. It's the tip. Okay, now whether it opens up or down is based on whether your equation is positive or negative. Your axis of symmetry, I'm going to come back over here to this one. Your axis of symmetry on this particular parabola is right here. If I were to fold my graph right along that line, see how it would be lying on top of each other? That's my axis of symmetry. With parabolas, it's always going to be a vertical line, which means your axis of symmetry will be x equals something. Because it's, and that I gave you x equals 0, that's for that particular one, but it's going to be x equals something, I'll put a box, it's going to be a vertical line. Okay, now mirror point, again I'm going to go back to my parabola. If I'm talking about this point right here, its mirror point is the point that it matches up with if you were to fold over the axis of symmetry. So if you're talking about this point right here, its mirror point is there. So I don't really have a good way to describe that, but that's what a mirror point is, or in a short written way. Okay, now if you don't have your calculator, you might want to pause this and grab your calculator real quick, because the last thing we're going to do is using our calculator. Let me make sure I have mine pulled up. Yeah. Okay, so what I want us to do is I'm giving you 3 points, and each of these I'm giving you the x and the y that goes with it. I'm giving it to you in a T-chart. I could also give it to you as a point like this. What I want us to go through and do is I want us to go through and I want us to write a quadratic model, which means a quadratic equation that models this set of information. So basically, I want to find a parabola that goes through those 3 points. Now, we're going to do this in our calculator. So what I'm going to go through and do is in my stat menu, I'm going to go to edit. Now, what that will let me do is edit these lists of information that are in my calculator. Yours might be blank if you haven't put anything in a list before. Mine has something in it. I really want to be able to put what's in our problem. So I'm going to just go hit the up arrow, and when my L1 right here is highlighted, hit clear, and it will clear that out for me. Now I'm going to go over and do the same thing in L2. You may not have to do this if this is the first time you've put anything in. Okay, and then I'm going to put in those 3 points. So I'm going to put in my x values first, and then I'll put in my y values here in L2. Now, just a heads up on this, your computer or calculator will by default use lists 1 and 2. So if you're good with that, it'll do that by default. If you put something in list 3, or you can scroll over and have some other lists, if you put it in some other list, you have to tell the calculator that, so just heads up on that. Okay, so I'm going to quit out of here, and I want the calculator to give me a model. So I'm going to go to Stat and over here to Calc. Now what I want it to do is give me a quadratic model. Now here they're going to have different types of regression. Regression just means take points and give you an equation that matches that. There's linear regression. They told us ours was quadratic, so we don't want a linear equation. There's quadratic regression. That's the one we're going to use because we're talking about a quadratic here. Later on, there's cubic regression. Cubic means there's an x to the third. Quartic regression, that means x to the fourth. So right now, we're only dealing with quadratic, so I'm going to pick number 5. Now remember I told you it will automatically put list 1 and list 2 programmed in your calculator to find the stuff if you just put in the regression. If you put stuff in a different list, you got to make sure to tell the calculator that. I put mine in list 1 and 2, so I'm going to hit enter. Now I don't know why the calculator comes up like this. I don't know why they couldn't just put the 3 here, put the -5 there, put the 1 there, but they don't, so you've got to do that yourself. But they're telling you what the A, the B, and the C is. So let me come back over here and let's write out our equation. So our equation, our A was 3, our B was -5, and our C was 1. Now, I wrote this as an equation, or as an expression. I should probably write it as an equation, so you could write it that way. It is a function, so you could also write it like this. Either one's fine. Okay, and one more of these. So same thing, they gave me the x and the f of x. This is like the y. So I'm going to put these in my calculator. And again, we want a quadratic model. So let me just clear this out. I'm going to go back to my list. Now I'm putting in the same number of items, so I think I'm just going to type on top of these. So -1, 1, and 2. Okay, 17. Oops, I'm in the wrong place. Okay, let me go back because I don't know what I did. Okay, 17, 17, and 8. Okay, quit out of there. And then I want to go get the quadratic regression, which is under, it's number 5 here. I put it in list 1 and 2, so enter. Okay, so here's my A, here's my B, here's my C. So let's write out our answer. So we have 3x squared, oh it's negative, plus 0x plus 20. Now because this is a 0 right here, I don't really need to write it. So here's my real equation, and you'll want to use either a y or an f of x here, set equal to that. Alright, so this is kind of an introduction to quadratics and a little bit with quadratic models. We'll continue on tomorrow.